Morning everyone. I'm Sudarshan Ambala, working as faculty in physics with Government City College, Hyderabad, Telangana. Today's topic is logic gates and logic families. Before we start the new one, I just want to summarize what we covered up into the last class. Last class we have seen the digital principle covering up number systems. All the kind of number system, decimal number system, binary number system, octal number system, and hexadecimal number system. We have studied how the conversion will take place from one type to the another type, and we have also studied the Boolean algebra, addition, subtraction, multiplication, and division rules. We have studied ones complement and twos complement, and took few of the examples subtraction using ones complement as well as twos complement. So today's topic, as I said, is logic gates. So let's have basically what gates are called or how the logic gates are defined. So logic gates are the fundamental building blocks of digital systems. The name logic gate is derived from the ability of such devices to make decisions in the sense that it produces one output level when some combination of input levels are present. Input and output of logic gates can occur only in two levels. So as we are talking only about the binary, because binary have only two digit or two bits, 0 and 1. So input and output of logic gates can occur only in two levels. Either it can be 0 or it can be 1. Or to name few, we can say high, low, true, false, on, off, 1, 0, closed, open. Now, what is truth table? A table which lists all the possible combination of input variables and the corresponding outputs is called a truth table. Means it depends on the number of inputs which we are giving as an to that particular gate. So all the possible combinations, the input given to that particular gate and what is the output. So if you summarize and put it into a table, then that is called a truth table. It shows how the logic circuits output responds to various combination of logic levels at the input level. Now, just took example, we just took two switches in parallel. If you see this, this is one switch and this is another switch, and these two switches are into parallel mode. We have given a source to this, and here we have put an I can say an LED at the output. So what will happen? Just try to understand. We have switch 1, switch 2, because these two, we can say these two variables are as an input to that particular circuit and the output is this one, Y. I can say this as an Y. So now for the first condition, how many combinations we have, possible combinations? These two switches can be open, or this out of these two switches, this can be open, this is closed, or this is closed, this is open, or both the switches are closed. So we have the possible combinations there are 4. What are they? Switch 1 off, switch 2 off. Switch 1 off, switch 2 on. Switch 1 on, switch 2 off. And switch 1 and switch 2 both are on. So what will happen to the output? If I say both the switches are off, so obviously there is no current flowing through this particular LED. So will there be any glow of light out of this particular LED? No. So I can say that off, off, the output is off. Similarly, I just kept this switch 1 as off and I put it this as an on. So from the positive terminal, the current will flow in this manner, and this is how it will pass through this particular LED, and the current closes with this negative polarity. It means there is a current in the circuit. So when I say that the switch 1 is off and switch 2 is on, there is a glow at the output. Because these two switches are in parallel mode of connection. Again, switch 1 on and this is off, there will be an output. And obviously, if I put both the switches on, there is a huge current flowing through this particular LED. So the light will glow at the output. So this combination, this possible combination of input variables and the corresponding output variables is called truth table. A logic in which the voltage level represent logic 1 and logic 0, because only two probability we have, either it will be 1 or it will be 0. Level logic may be positive or negative. So we have the condition whether the logic is positive or negative. So what are the conditions? A positive logic is the one which the higher of the two voltage levels represent the logic 1, and the lower of the two voltage level represent the logic 0. That case, it is called as a positive logic. In reverse, if I say negative logic is the one which the lower of the two voltage levels represents logic 1 and higher of the two voltage level represents the logic 0. So it is in reverse form. So then that is called as a negative logic. You can see here, this is a positive logic example. Logic 0 low, which is at 0 voltage, and logic 1, this is a high, which is a plus 5 voltage. Whereas negative logic will be for the logic 0, this will be plus 5 voltage, and logic 1, it will be 0 voltage. So this is the two difference between the positive and the negative. Now we have the classification of the logic gates. What are the logic gates? So we can have few basic gates or universal gates and few special purposes gates. Basic gates are nothing but these are called as fundamental gates. These three gates, AND gate, OR gate and NOT gate are called as fundamental logic gates. These two are called universal gates, NAND gate and NOR gate. It is pronounced as NAND and NOR. So NAND and NOR are called as a universal gate. In the sense, using this particular any one of the gate, if I take an example of NAND gate, I can construct only using NAND gate, I can construct AND gate, OR gate, NOT gate, or NOR gate. Similarly, only using NOR gate, I can construct all these three fundamental gates. So that's the reason NAND gate and NOR gate are called as universal gates. And for the circuit requirement, as per the circuit requirement, we have a special purposes gates which are called as an XOR gate or XNOR gate. It means exclusively OR gate and exclusively NOR gate. So these are all the gates which we will be studying into our next slide. Let us see what is AND gate. AND. An AND gate has two or more inputs but only one output. The output assumes the logic 1 state when both inputs are at logic 1 state. It means the output is 1. The output is 1 only when both the inputs are 1. The output assumes the logic 0 state even if one of its input is at logic 0 state. It means the output will be compulsory 0 if any of the input is 0. This is called as a symbolic representation of an AND gate. This is a straight line and this is how we need to draw. And here we have taken an AND gate with two inputs, A and B. So what is the output? Output is called as in Y, which is equal to A dot B. We have seen in the Boolean algebra, all the arithmetic we have done it, addition, subtraction, and multiplication. So this is nothing but multiplication. Y is equal to A dot B. Now we'll just try to understand. Once again, I'll define the AND gate. An AND gate has two or more inputs, but only one output. The output assumes the logic 1 state when both inputs are at logic 1 state only. Let us see the truth table, how it behaves. So AND is nothing but, how many possible combination for the input variables we have? Because there are two inputs, A and B, the combinations will be 2 to the power of number of inputs, because binary have the two numbers, right? So 2 to the power of n. Small n are number of inputs given to the particular gate. So 2 to power of 2 here, because we are giving 2 input to this particular AND gate. So 2 to the power of 2 is 4. So how many combination we will have? 1, 2, 3, 4. 4 combination. Now let us see what will happen. If I give 0 and 0 as an input to the AND gate, the output will be 0, because y is equal to A dot B. So 0 dot 0 is equal to 0. What's happening now? 0 and 1. A is 0, B is 1. So y is equal to 0 dot 1 is nothing but again 0. Now let's reverse it. I'll give A as 1 and B as 0. So 1 and 0. So 1 dot 0 is nothing but output is 0. Now if both the inputs, I'll give as a 1 and 1. See the last combination. So this is 1 and 1. So now 1 dot 1 is how much? The output is 1. You can see that 1 dot 1 is 1. The output is 1. It means if you go back and understand the previous definition for the AND gate, the output is one state when all the inputs are at one state. Got it? So because we have taken all the inputs as in one state, the output is 1. And output is 0. You can see for all the three other combinations, the output is 0. If any one of the input is 0. Now you can see that out of these two, one is 0. This is 0. This is 0. So this is 0. It means, what is the true definition for a AND gate? AND, in English we can say that AND. A and B. When input A and B are high, the output is high. Now understood, I hope. Say this, when A input and B input, when A and B are high, the output is high. It means whatever the number of inputs you have given to the AND gate, all should be at one state, high state. Then only the output will be high. So that is an AND gate where I say that the output y is equal to A dot B. This is a truth table. Thus we can say that the symbolic representation of an AND gate, and this is a truth table. Now let us see the construction of an AND gate using diodes. Now we will see an AND gate which is constructed using diodes. We can construct using diodes, or we can construct using it through transistors. So if we use a transistors, then the circuit is called as in TTL. It means transistor logic. And here, because we have used the diodes into that, so this is called as in DDL, diode logic. Now let us have let us try to understand the construction of this particular circuit diagram. So here we have two diodes. This we label this as D1 and this is D2. Then this is a cathode to the diode. This is cathode again. And these 2 points we have given as in point A and B. It means we'll be giving as an input to this particular gate from A point and B point. And here between this point and the ground point, we will measure the output. And this is a load resistance we have taken plus 5 voltage, which we have to give to function this particular circuit. So this is plus 5, and between this point and the ground, we will measure the output. This is a load resistance, point A and point B. So here we can have two switches and we can supply two sources to point A and B to fulfill the possible combination as 0, 0, 0, 1, 1, 0 and 1, 1. Okay, so now we will understand the first condition when A and B are 0. Let us see this condition now. Now, the same diagram for the first condition when A is equal to 0 and B is equal to 0. What will happen if I say that A and B are 0? In the sense, what will happen? The cathode of each diode is grounded. You can see that this was the cathode. See, once again, I'm going back. So this is a cathode and this is a cathode. Now you can come back. So the cathode of both the diodes are grounded. You can see both the diodes are grounded. Therefore, the positive supply forward biases both the diodes in parallel. So when I say that the negative polarity of this particular diode is connected to negative, and here also both the diodes are in negative, it means diode D1 and diode D2 are in forward bias. It means it is called as a conducting stage. So when the diodes are in conducting stage, it means normally we say across the output there is a current flowing into it, isn't it? But the current will be flowing where? The current will be flowing through that particular resistance RL. But we are not measuring an output across this particular resistance. We are measuring output across point this and between the ground. So I repeat that when A and B are 0, the cathode of each diode is grounded. Therefore, the positive supply forward biases both the diodes in parallel. Forward bias, what does it mean? It means the diodes are conducting. So the conducting diode has very low resistance and output voltage will be nearly 0. Okay. So the whole voltage VCC will be dropped across the load resistance RL. The complete voltage will be dropped across the load resistance RL. And hence, when I say that A is equal to 0, B is equal to 0, Y is equal to 0. So this is the first condition explaining using the diode construction of AND gate. Let's see when A is equal to 0 and B is equal to 1. Let us see when A is equal to 0 and B is equal to 1. Now you can understand by yourself. Again, the cathode of this particular diode is grounded. And what about this? The cathode of this particular diode is connected to the positive polarity because we have given B as a 1. It means A is 0 and B is 5 voltage. A is 0 and B we have given as a 5 voltage. It means what will happen to the diode D1? The diode D1 is grounded and diode D2 is, this is reverse bias. It means this is forward bias and this is reverse bias. So what will happen? Because of the diode D2, obviously because it is into the non-conducting state, it is in reverse bias, there is no current. And as we say that this is a conducting stage, this is in forward bias, there will be a current in the circuit. But that current, the voltage, complete voltage drop will be across the load resistance RL. So what will be the output? When A is equal to 0, B is equal to 1, then the output is 0. Once again I repeat, when A is 0 and B is equal to 5 volt, the diode D1 is grounded and diode D2 is reverse bias. This is open, it is a reverse bias. Due to reverse biasing, the diode D2 stop conducting. The diode D1 will not conduct due to forward biasing. Therefore, the output will be 0 as seen in the, as shown in the figure. I hope this is clear now. Now the second condition is when A is equal to 1 and B is equal to 0. So what is happening when A is equal to 1 is A is 5 voltage high and B is 0 low. So in this case, the output is short circuited to ground through diode D2. Hence output is again 0. So again you can see that this particular diode is reverse bias and this is in forward bias, and here the output across these 2 points will be 0. So I say that 1 is input and this is 0 it is 0. So for 0, 0, 0, 0, 1, 0, 1, 0, 0, and 1, 1, what will happen now at the last stage? When A and B are high, both the diodes are non-conducting. Since the diodes are off, there is no current through the load resistor. So what will happen? If I say that this is reverse bias and this is reverse bias, will there be any current flowing through this particular load resistance? No. So entire the supplied voltage will be dropped across where? Across this point and the ground. So I'm repeating, when A and B are high, both the diodes are non-conducting. Since the diodes are off, there is no current through load resistance. The output is equal to the supply voltage VCC, which is nothing but a 5 voltage. So here, if you measure, the entire supply voltage plus 5 will be dropped across these 2 points, this one and the ground. So I can say that when A is equal to 1, B is equal to 1, the output is 1. So this is called an AND gate. AND in the sense, once again I'm repeating, when A and B, or when all the inputs given to particular gate are high, then only the output will be high. So that is called as an AND gate. So this is a circuit diagram using a construction of a diode using a construction of an AND gate using diode. This is a construction of an AND gate using transistor. So you can see that this is a Q1 transistor, Q2 transistor, and a Q3 transistor. We are measuring an output across this point and to the ground. This is the supplied voltage, and this is the input A and B. So in the same manner it will work when, now let us assume A is equal to 0 and B is equal to 0. It means both the transistors are off and off. Then this is triggering into on, but output here across this point and the ground will be 0. So when A is equal to 0, B is equal to 0, output is 0. When A is equal to 0, B is equal to 1, it means this is off, this is on, but the output here measuring across this point will be 0. Similarly, when A is equal to 1 and B is equal to 0, then the output is 0. What will happen when both the inputs are high? It means greater than the 0.7. It is a potential barrier voltage. So greater than, we are giving a 0.7 voltage so that the current rises into the circuit. So this is on and this is on, but this is making less than 0.7 voltage. So this is making less than, because it is less than, this is off. So output is measured across this particular point. So when A is 1, B is 1, the output is 1. Now this is how it looks like, Previously we have taken an AND gate with only 2 inputs, but this is AND gate having a 3 inputs. So here you can see that this is one AND gate, A and B are the input, and the output of this particular AND gate is given as an input to one more AND gate, including a new input as a C. So now how many inputs we got it to the AND gate is A, B and C. So this is a symbolic representation of an AND gate which is having a 3 inputs, A, B and C. So what is the output now? As we have studied in the case of 2 inputs, Y was equal to A dot B. So here it will be A dot B dot C. Now just see here, go through this, because as I said, how many combinations it will have now, how many inputs we have given input as in 3, and this is all about the logic, the binary numbers. Binary numbers are how many? 2, 0 and 1. So inputs are 3, so it means 2 to the power of n, I have told you. So 2 to the power of n is nothing but 2 to the power of 3. So 2 to the power of 3 is 8. So see here, 1, 2, 3, 4, 5, 6, 7, 8. So 8 possible combinations are there for the input. Okay, and this is the output. Output is y. Y is equal to A dot B dot C. So what is happening now? Each case you understand, 0, 0, 0, A0, B0, C0, the output is 0. 0 0 1, it is 0, 0 1 0, it is 0, 0 1 1, it is 0, 1 0 0 0, 1 0 1 0, 1 1 0, it is 0, and the last is 1 1 1, the output will be 1. All the inputs, unless all the inputs are high, the output is not high in the case of AND gate. Any one of the input, if it is 0, see here, this is only one input which is 0. Any one of the input is 0, then the output definitely will be 0. So if you understand from the truth table, see, this all output are 0 only when the output is high, when all the inputs are high. Now, this is an AND gate using an IC. So this IC called 7408, which is readily available in the market. So you can see the IC, which is having 4 independent gates, 1, 2, 3, 4, which performs the logic and functions. Okay, so this is a gate, this is an integrated chip called IC7408. So readily we can have the 4 independent gates into that. Now this is how the label are done. This is pin number 1, 2, 3, 4, 5, 6, 7, and opposite to 7 will be 8, then 9, 10, 11, 12, 13, 14. So this is 14 pin IC called 7408, which is having 4 independent AND gates. Got it? So this is called A, B, this is Y output, A, B, Y output. This is ground for all the gates, common ground. Then again, this is A, B and Y output, A, B and Y output, and this is positive polarity. So seventh one is ground, seventh pin is ground, and opposite, diagonal opposite to that 14th pin is plus. So this is plus VCC and this is minus, we can say that. So 4 independent. Now what is the output of an AND gate? A dot B. So we can say, we can have a truth table in this manner. Inputs are A and B and the output is 1. So input A and B, when it is low, low, the output is low. It means 0, 0, the output is 0. Low, high, low, high, low, low, and high, high, high. So you can use any of the gate for your practical purposes. Only thing is you have to see that how the points, how the pins are considered. Like here there will be a white color notch. Wherever on the IC there is a notch, that particular pin is called as pin number 1. And subsequently 1, 2, 3, 4, 5, 6, 7, 8, 9, or whatever the numbers we have. And then opposite to that will be the next number. And this is how we close all the numbers. So this is called IC7408. Just for a verification, you can see that you can give a power supply plus voltage here and make it here this particular pin number 7 as a ground. And then we have considered this particular one independent gate, the first AND gate. The input to this is A1 and B1, output will be Y1. So these are 2 inputs, 0, 0, 0, 1, 1, 0 and 1, 1 we will be giving to this particular 2 inputs A1 and B1, and output is Y. So to this output, for a proper intensity of this particular LED, we have used one resistance of the value of 330 ohm and one LED into this. So if you give the condition like 0, 0, it will be 0, 0, 1, 0, there won't be any glow in the light. 1, 0, no glow, and but if you give input as a 1 and 1, then definitely this will be glowing, the output will be. Just to double check the pin numbers when working with ICs, please, you have to see that this is the notch over there, white kind of a dot will be there. So wherever you find this particular dot, that particular pin is called pin number 1. Then serial number 1, 2, 3, 4, 5, 6, 7. Opposite to 7 will be 8, 9, 10, 11, 12, 13 and 14. Okay. So here in the case of IC 7408, this pin number 7 is ground and pin number 14 is positive plus VCC. Now we can have the breadboard practically and do the same. So here we have connecting. See, you can see that this is a pin number 1. So pin number 1, this is the breadboard. I hope everybody know that. So this is pin number 1, pin number 2. So pin number 1 and pin number 2 are the two inputs. See, this is an A input and this is an B input. These are all interconnected. Okay, these are all interconnected. So this is pin number 1 A, pin number 2 B, and pin number 3 was A1, B1, and this was Y1. So to the Y1 we have given a resistance of 330 ohm. Here, according to the color coding, like BB Roy goes to bring very good white. According to that, we can find out the color combination of this particular resistance. So third is given to the resistance. Output of the resistance again given to the LED, because these are interconnected, this point and this point, and the other terminal of the LED is connected to this. So which we have connected a ground. So this is how it works. And because this is a pin number 7, so these are all interconnected to each other. So from here we have connected to the ground, and this all horizontal will be interconnected to each other. In the breadboard, these are vertically interconnected to each other, and this horizontal will be interconnected to each other. So 7 is connected to ground. Here you can see it, and the other terminal is connected to the ground. This is how we have given a ground. And here, because 7, this is the 7 and this is the 14. 14 should be connected to the positive polarity. So from here we have taken a wire and connected over here, and this to this we have connected a source. So this is a source, this is plus, and this is minus. So this is how it works. We are using an IC 7408.